Ladies and gentlemen, hello and welcome back once again to the Bloor Group's webinar series. I'm very pleased to have a very special guest today with us, a former Gartner analyst and all-around expert who's been in the field for quite some time. Sumit Pal is with us today. We're going to talk about knowledge graphs and the whole concept of a center of excellence. And if you were here in the pre-show, I was chit-chatting with Sumit about all the different applications of knowledge graphs, in particular within the context of all this generative AI. And beyond that, foundational models. Generative AI is just one flavor of artificial intelligence. There are many other forms of AI. But I think, as we've been discussing, by and large, we're going through a major transformation in enterprise software now and in how business gets done, quite frankly. And these AI models are going to subsume most of traditional enterprise software sooner or later. Some of the low-hanging fruit is definitely in the customer service space, obviously in copywriting and content creation, things of this nature. But you can rest assured that business intelligence, analytics, most of what enterprise software does is going to find itself in the crosshairs of these foundational models. And here's the good news, folks. Graph, especially knowledge graphs, are extremely valuable at being able to true the wheel of Gen AI, if you will. In other words, whether it's part of a RAG architecture, and that's probably the most of what you'll see, or some other type of implementation, perhaps fine-tuning, knowledge graphs provide a tremendous foundation of the concepts and constructs and key ideas that you're trying to manage with your enterprise. So with that, I'm going to hand it over to Sumit Pal after my long intro there. Knowledge Graph Center of Excellence. Take it away, Sumit.
Thank you, Eric. Thank you for the introduction and giving us the opportunity to discuss about knowledge graphs and center of excellence around it. Hi, my name is Sumit, and I'm delighted to have all of you here. My role here at Ontotext straddles between marketing, pre-sales, and solutions engineering to bring in thought leadership across various industries for adoption of knowledge graph and semantic technologies. So I'd like to welcome you to this buffet, the data buffet, right? This is a picture from Matt Turk's Mad Landscape 2024. I'm not sure how many of you have seen it. There are about 2,400 logos here on this one single chart. It's called MAD for a reason, because it covers machine learning, AI, and business intelligence and data and data. And what we see here is the data ecosystem today is crowded with shiny objects, dazzling buzzwords, and data ecosystems have sort of become data jungles, where data teams are struggling, grappling with the high entropy in this ecosystem to create in this disaggregated system a functional modern data experience. What is happening as a result of this is the data skills have become sort of the most sought after skills, and job descriptions are shifting as quickly as the new tools hit the market. This unbundling of the data ecosystem has led to the problem that there is no one end-to-end tool, causing data teams and data personas to duct tape different products and frameworks to build these end-to-end automatic or automated, agile, and repeatable data-driven systems. Let's look at this data maturity spectrum, right? We call it the DIKW pyramid, which we'll show in the next slide. All organizations today are on this data journey, but it turns out that almost every organization is stuck at the information layer. They find it very difficult to cross that chasm from information layer to the knowledge layer. They have no dearth of data. The data is hidden in data lakes, lake houses, data warehouses. There's lots of data, but it lacks context to make the connections across these data sources, across these data units to gain valuable insights. So we have this thing where we say data everywhere, not a drop of insight, neither a drop of context. We have heard about big data, wide data, and so on. But actually, no one talks about the context aspects. And as we get more and more data, the context gets diluted unless it's managed well. So this is the DIKW pyramid. And what we see is most organizations just stop at that information layer. There are some organizations that can make this transition to the knowledge layer through the use of graphs and knowledge graphs. And the critical step, the critical misstep, I would say, is in adopting AI and data technologies is the disconnect, the major disconnect between business needs and technology. Organizations rush to embrace technologies without clearly defining the problems they are going to solve. They bring in different technologies in a more bottom-up approach instead of taking a top-down approach to solve business use cases that leverage data and the technologies, and hence miss the fact that they are building solutions that often don't serve the business. And this is where we come up with this term called bad data tax. In this race to become data-driven, most of the efforts of most organizations have resulted in a tangled web of data integrations, often point to point, and integrations as well as reconciliations across these data silos. And this has resulted in a huge cost to the organization, often 40 to 60% of an enterprise's annual technology spend, which amounts to millions in dollars. We call this the bad data tax. And these investments often don't translate into insights needed to deliver better decisions or build better processes. And hence, there is a solid justification in every organization to fix this, so that those who need access to the data can convert it to insights and drive business decisions and processes, and make data available and accessible in the right format, in the format that is flexible, accurate, and machine readable. It's been also seen that, from my experience at Gartner, when I used to talk to customers and clients all the time, it seems that only half of the CDOs are able to drive innovation using data, and just about 40% of the CDOs manage data as a business asset. These are some of the numbers that we have seen. Also, comes to my mind is about 20-25% of the CDOs also do not have a single point of accountability for data within their organizations. This was a survey done by Salesforce a year back, where they illustrated this point that 90% agree from the data teams that the need for trustworthy data is higher than ever. And today it's even more, because it's again the whole idea about garbage in, garbage out. If you're feeding garbage to your AI technology, you're going to get garbage out. So this sort of summarizes, this mind map sort of summarizes what we discussed in terms of challenges that most organizations are facing. One of the biggest challenges, you will see the one which is right at the bottom, is also about findability. Most organizations, most data personas in most organizations cannot link the data, cannot find the data, where because of lack of context. And McKinsey and IDC had done a research about a few years back, where they found out most data personas in organizations spend about 30% of their time just finding the right data for their use case. So if we ask ourselves these questions, right, why do most data lake efforts fail? And why is data getting increasingly harder to find? Why existing data catalogs are not working for most enterprises? The reason is, to be effective to work with data, it's not just technology and more data. It requires context and semantics to make the data more powerful. What has happened is we have allowed the data to lose consistency and precision of meaning, because most organizations haven't thought about context and semantics as they build their enterprise data platforms. So data by itself is powerful, but the challenge is again the context. As data has grown in volumes, the need for automated context has grown as well. And that's why organizations cannot aspire to, or cannot dream to become data or AI driven unless, in my mind, they are context driven. And data context here includes both business, technical, metadata, governance, privacy, accessibility issues. It is context that makes data more valuable. Okay. And in my opinion, data engineering will still remain a huge cost center for most organizations until it matures from becoming a pure ETL-oriented or an ELT-oriented approach to an ECL-oriented approach, where C is the context, by leveraging knowledge graphs and ontologies for knowledge management. So what is a knowledge graph? Knowledge graph is sort of a network of entities representing real-world domain objects like people, organization, as well as concepts, topics, and their semantic relationships and attributes. Knowledge graphs, with their emphasis or with their more stress on semantic relations between the entities, creates the context for both humans as well as machines to do automated reasoning. And knowledge graphs go beyond just simple storage and querying of data, and it focuses more on the idea of definitions of the connections between the entities. And as you will see, it requires connecting the dots across most of the organization where most organizations struggle. And knowledge graphs help to build this foundational semantic graph layer by semantically linking the data across the silos, whether it's structured, unstructured, semi-structured. And that reduces or eliminates bottlenecks in the process of becoming data-driven. What makes a knowledge graph useful and powerful is that semantic model, the ontologies, the taxonomies, that includes domain concepts and their interrelationships, their hierarchies, their dependencies. It is this semantics that actually enriches data with the context that both machines and humans can interpret unambiguously. So knowledge graphs actually give a holistic view of the data, revealing these intricate hierarchies within the data, the precise definitions that gives meaning to the data. As I said earlier, data by itself is powerful, but context is what gives the meaning and real value to the data.
Real quick, Sumit, we got a question from the audience, and it's a very good question about data literacy. It seems to me, and you've already mentioned data catalogs. Obviously, data catalogs are great for improving data literacy, because the whole point is to capture the definitions and the meanings of these concepts and to share them in a useful, accessible way. But it seems to me a knowledge graph is an incredibly powerful tool for improving data literacy. What do you think?
Absolutely, absolutely. That's a very good question and very good point, that knowledge graph has embedded in it the semantics and the context, as I keep saying again and again, which are, again, very domain specific. A lot of the times, the data literacy aspect is understanding the data and understanding the nuances associated with the data, which is oftentimes embedded in the heads of domain specialists,
Right.
data stewards, even data engineers. They are encoding all those business rules in their SQL code. And that sort of, decouples the data from the logic. Whereas in a knowledge graph, where everything is connected, in a knowledge graph, the data and the metadata are in the same place. That provides enormous benefits from a data literacy perspective. Spot on.
Okay, go ahead.
So the knowledge graph platform adds semantics and meaning to the data, as we said. But how does it do it, right? It treats the connections between the different entities as relationships are first-class citizens, using, in a knowledge graph or in a graph-based technology, using nodes, edges, and labels to depict these entities, their interrelationships and properties. It's this semantic layer that comes out from it that contextualizes the data, giving it meaning, a formal representation and meaning, making it machine interpretable. The other advantage of knowledge graphs, especially built with RDF stack, is it follows open standards. Everything in a knowledge graph that is built with an RDF stack is thereby reusable. It's interoperable, and it's very amenable to data sharing with unambiguous semantics. Also, the other aspect of graphs is graphs can be very easily accommodated to make changes, because enterprise data systems are always changing. And graphs provide that flexibility of flexible schema to make adjustments and changes. This shared meaning resolves a lot of the ambiguities associated, especially when you're building, let's say, a simple data pipeline. As you're handing off data or bringing in data from operational systems to analytical systems, you realize there is a sort of an impedance mismatch happens where the terms can mean something else in the operational systems while it means something else in the analytic system. That's where knowledge graphs, with their ideas of semantics, with ontologies and taxonomies, removes these ambiguities. Now, there are different ways in which semantic technologies increase the value of data. First, it helps in data integration. It's not, we all do data integration. Data integration is probably one of the richest tools you would see in that first slide or the third slide that I showed you. But those are all doing data integration with a lot of the code, with a lot of the business logic in the minds of the people who are implementing it. But with knowledge graphs, we do what is called semantic data integration, where you're semantically joining the data across different data silos. That's why you will see a lot of the data fabrics are powered with knowledge graphs. The second aspect is data quality, as it captures relationships between things and adding context through ontologies, as well as doing inferencing through the relationships. And a side benefit of this is doing entity resolution. So we don't have to duplicate nodes or deduplicate nodes in a graph. A knowledge graph built with RDF stack, you cannot have duplicates. The system will not allow you to have duplicates. It removes that whole soft data engineering aspect of, where we do deduplication is a huge set of work that needs to be done. But with knowledge graphs, when you're ingesting data into a knowledge graph, especially with an RDF stack, it will prevent duplicates from happening. So all this leads to trust with data validation, lineage, and provenance. Out of the box, a knowledge graph built with RDF provides you provenance. Think about the tools that provide you provenance and lineage, how much work they have to do to provide you the whole lineage stack. While with knowledge graphs, built-in versioning capabilities and capabilities to do provenance, there is a provenance-based ontology. It comes to you out of the box. Same thing with what we call FAIR principles. Data, in our opinion, needs to adhere to these FAIR principles, which is findable, accessible, interoperable, and reusable. And knowledge graphs provide you with all these capabilities. So this slide sort of summarizes all that we discussed earlier about the capabilities of knowledge graphs to remove ambiguities, to represent data consistently, and integrate and unify the data sources. Now, this graph foundation, this as what I've been talking about, graph foundation with a knowledge graph based with taxonomies and ontologies enables you to do these things that we have all been doing in a much more seamless, much more cost-effective way, where you get these new capabilities out of the box. And how does a knowledge graph do it? It does it with these semantic standards. Semantic standards have been there since the beginning of the century or end of last century, where it uses identities to represent entities, to represent the concepts. And all these result in these foundational capabilities that are very essential to the whole data management practice to provide things, data quality with validation, capabilities of reusing, of governance and lineage. And on the right-hand side, you see the value drivers of all these foundational capabilities. Now, this is the outline of an enterprise knowledge graph platform and how it interplays, how it interconnects with the different tools and engines that we have in most organizations in their legacy systems. And it supports two major design patterns here, the semantic knowledge hub and the semantic data fabric. The knowledge hub part of it uses knowledge graphs to manage documents and unstructured content. Unstructured content is all around us and improves the way the documents are found, especially with the relevance and with their precision and accuracy. The data fabric side, the semantic data fabric side, is the pattern that provides better unified access across multiple structured or semi-structured data sources. And its objective is to enable querying all of them as if it's a single federated database or a data source. In both these use cases leverage the semantic metadata, which, as you see in the center, is the conceptual model, which is based on domain-specific ontologies and other metadata capabilities. When you do this, it makes data much more discoverable, interpretable, and unambiguous, and also consistent. And at the bottom, we see to manage these platforms, we need different engines and capabilities. We include integration with LLMs, with machine learning tools, especially with text analytics, document stores, maybe full text search engines and vector databases for doing and again, integration with other LPG-based graph sources to do graph analytics. And these are some of the major use cases that Ontotext has been doing in the last 20 years to solve some of these data management problems, along with the high-level architectural patterns that support those use cases. Now, to show you what some of the next slides are mostly quotes, which I'll quickly go through. You can read them once these decks are shared. However, there is one particular example where even Gartner now has been talking about the last 5-7 years about the value of graphs and knowledge graphs, as well as the semantics and the metadata needed to become successful with your data management practices. And if you have seen Gartner's 2004 Impact Radar, you see knowledge graphs at the center here, where they're talking about knowledge graphs with the metadata aspects, how knowledge graphs can help with Gen AI and LLMs. One particular example I'd like you to look at, and this is available even on YouTube if you search, in a Knowledge Graph Conference 2022-23, Gregor Wobb he's the head of data architecture at UBS, spoke about implementing their next generation data management based on this foundational graph layer, knowledge graph layer. They're doing all the things that sort of I highlighted in the above slides, building common data models and ontologies with a unified meaning that could be shared across the organization. They built this with schema.org, with all the shared models and schemas that were standardized across the organization. They built a data service to enrich their data by converting it into a knowledge graph based on these shared ontologies. They cataloged all their data assets to build this conceptual layer and map data to this layer to power their downstream applications, analytics, and data products. So before I finish, just the last two slides, what is this graph center of excellence, right? So how can something like this be implemented in large organizations? Most large organizations also have, few isolated graph projects for specific niche projects and use cases like fraud detection or recommendation. But this data management case is very different. We see companies like UBS, which have gone down this path, and they have adopted this graph center of excellence with strategic prioritization of graph use cases across the organization with C-suite sponsorship to start with a single C-level executive who champions the strategic vision to build or bring in knowledge graph-based approaches to solve the data problems. And finally, these are some of the key takeaways. In order to become data-driven in the age of AI, requires organizations to shift to a more connected and contextualized aspect of thinking about their data, with graph technologies as the foundational layer for their modern data management requirements. Because graph enables semantic data integration, traceability, ambiguity, resolving ambiguous entities, promoting sort of consistency, sharing, reuse, and following the fair data principles to connect the dots across the organization with this semantic graph layer. Using ontologies and taxonomies and controlled vocabularies, which are domain-specific models for the organization. That was in short about a quick run through of the graph approach.
That's pretty impressive. We got a couple questions, and I know you have to run in a few minutes here, but Couple of quick questions. How does a graph maintain lineage to the source once it's been loaded? Is that in the relationships between the entities, or how do you actually preserve lineage?
Yeah, so if you have to preserve lineage, then both there is a specific ontology that can be incorporated into the graph. It's called Provo. Provo is a well-known publicly available ontology that is based on the RDF stack that, when incorporated into your knowledge graph, can help you to do sort of what current data lakes also are doing in terms of doing time travel, in
Hmm.
terms of doing versioning, to keep tag of how the data is morphing as it is moving through your system. Because remember, your data pipelines are not getting replaced by knowledge graphs or the graph layer. The graph layer is just the metadata around all your data workflows. This metadata will help you enrich your provenance, lineage, time tracking, versioning, those aspects of it.
Yeah, right. I mean, I'm reminded of how we got here with the whole concept of data warehousing. And years ago, we realized that you cannot analyze, you cannot run queries on operational systems very effectively. So we pulled out key aspects, transactional data from these systems, but in doing so, stripped out all the context. And what you're suggesting here is that the graph, especially via a center of excellence, can preserve all of that context, which can then be leveraged downstream in any application, whether it's a data warehouse or a BI tool or just some front end that a user has to get access to information about customers or products or whatever. Is that about right?
Exactly. Because as we move from one system to other, right? As we are making, a lot of organizations are copying data, and copying data is bad, right? And
Right.
as you're moving data, each of these handshake points, there is a lot of information that is getting lost in translation. And the knowledge graph, the graph foundation layer, helps to capture them and interconnect them. What has happened, why it has happened, and what was the reason it happened, right? So you're spot on, Eric, in terms of that kind of an interpretation. Yes.
Yeah, we got a couple more questions here. One was, could you explain the difference between a data vault approach, data vault modeling approach, and a knowledge graph?
That's a pretty long discussion in terms of a data vault versus a knowledge graph. However, please reach out to us. I would say it's an interesting conversation. Reach out to us and we'll be able to explain to you how what we are saying is, yes, the graph model with the knowledge graph in an RDF. So knowledge graphs can be built with an RDF data model or an LPG data model.
Hmm.
RDF data model by itself has the semantics and the context associated with it. Now, the data vault model or any of the other data modeling, they are more at the logical layer, while the knowledge graph is more at the foundational layer or at the implementational layer.
Hmm. Interesting. We got a bunch of good questions coming here. I'll just throw a couple more at you with the time we have left. One attendee is asking, how can we ensure the scalability and efficiency of querying and updating large-scale dynamic knowledge graphs while maintaining data consistency and minimizing latency? I mean, how do you maintain performance over time?
Now, one of the things is, so don't think about copying your data in from your source systems into knowledge graphs, right? Knowledge graphs are more about the metadata aspect of it, right? When you're doing graph traversals or querying a graph where you have billions of nodes, a lot of our customers have knowledge graphs where the metadata as well as the instance data runs into millions of nodes and edges. However, your knowledge graph is not your OLAP system where concurrency and latency is like that deadly combination where you need high concurrency and low latency, right? Here you are doing most of the traversals or most of the querying of the knowledge graph for figuring out the dependencies, for figuring out, as maybe one example, how the whole traceability happens, how the lineage happens as you have to go traverse the graph. But you're
Right.
not doing aggregations, right? Where you are rolling up data or doing a lot of analytical type, OLAP type, reporting type queries.
Gotcha. There's one last question here as well. And folks, for any unanswered questions, we will pass these on to Sumit. He can get back to
Sure.
you. To
Absolutely.
be able to design and implement knowledge graphs, do I need to learn graph databases or vector databases? Well, vector databases, of course, are purpose-built really for large language models, and they represent entities like um, concepts, people, etc. They represent as vectors, so as
As embeddings, yes.
mathematical formulae, right?
Yeah.
So there's always going to be a lossy capacity with storing something as a vector because you're converting it from text or imagery into a mathematical function. So they're different. They're different entities. They
Correct.
do have a lot of overlap. But final thoughts from you, Sumit. Go ahead.
Yeah, they are totally different things, right? Vector databases are mostly to store the embeddings from your concepts, from your data, from your instance data into an embedding format and store it and retrieve it quickly. Retrieving it quickly is what vector databases do well because of support for indices and all that. Now, a lot of the existing databases, whether it's relational or non-relational, are also adding vector capabilities, right? Graph databases are also adding vector capabilities. We at Ontotext integrate with vector databases. Choose your own or bring your own vector database and we'll integrate if you have to store. Like that's the way we do graph RAG,
Hmm.
where we build on top of RAG with graphs, store the embeddings in an external vector database. We could add vector databases on our own, but right now we don't see a huge need for it. But vector databases and graphs are totally separate things.
Yeah. And the last question, I'll answer this. You tell me if I'm wrong. An attendee asks, is it a separate knowledge graph ontology database for each use case you deploy? Not necessarily. I mean, it
No.
could be. There are different ontologies that make sense for different chunks of data, basically, but you do want to reuse the ontologies that you deploy, right? Real quick.
Absolutely, yes. Different use cases can have an overlap of different ontologies, and that is where the knowledge graph platform is meant for sharing, for reusing. But again, if it's a siloed use case, you could definitely use it.
Wow, well, this has been fantastic. Thank you so much for your time. Sumit has to jump to a customer call. Customers always come first. But thank you so much for all these excellent questions, folks. We'll be sure to pass these along to the Ontotext folks. And this is the second in a series of three. So we'll have one more webinar coming up on the bad data tax. So, and if anyone wants to be on a show like this, send me an email, info@dmradio.biz. That comes right to me. And with that, we'll bid you farewell, folks. Thanks so much for your time and attention. Thank you, Sumit. We'll talk
Yep.
to you soon. Take care.
Thank you, Eric. And send me the questions, please. I think you will have it in the database somewhere, right? Yeah.
Yes,
Okay.
indeed.
Thank you.
Bet.
Bye.
All right, take care, folks. Bye-bye.